Hello everyone. Let us see here what is the semi-periodic signal. So before going to find out what is the semi-periodic signal, let us find out what is the signal here. So what do you mean by the signal? Here we are the humans. That means we are the complete universe is surrounded by the different types of the signals. We are using the signals for the communication purpose, for your networks, for Wi-Fi's and different things. That are nothing but the signals. That means if we consider one example, let us say the humans. As I am speaking, the signal which we are using for the communication purpose. So here let us see, I am speaking here. So what is that? One signal is transmitted here and that signal will be reaches to the another person. And whatever I am speaking, that signal or that thing will carry some information. That means that physical quantity will carry some information. So here what do we mean by the signal? Any physical quantity that will contain some information that is nothing but the signal here. So here what do you mean by the signal? Any physical quantity which is having some information, that is nothing but the signal. So whatever I am speaking, that is the physical quantity and that is nothing but the signal because it is having some information. And this signal will vary in this complete space and that will be depend or not dependent on the different variables. So the signal which is having the physical quantity and which contains some information and varies in the complete space and that will be depend or not dependent on the complete variables, that is nothing but the signals. So basically this signals any for communication purpose, if we use different types of the signals, that will come under or that nature is nothing but the signal. So here any physical quantity which contains some information, that will come under the signals. Now these signals will classified into two types. One is the aperiodic and second is the periodic signal. So let us find out what is periodic and the aperiodic signals. So the periodic signals, that means any signal which is having some pattern and that will be continuously repeating at a particular interval of time. So that signals will come under the periodic signal. And if suppose any signal which is not repeated after a continuous interval of time, in that case that signal will come under the aperiodic signal. Again I am repeating, what do you mean by the periodic signal? Any signal which is having some pattern and that signal will repeat itself after every regular intervals of the time period, that signals will come under the periodic signals. And if suppose any signal which is not repeating itself after every particular period of time, that will come under the aperiodic signal. So the periodic signal, basically the sine wave, you can say the triangular wave, the square wave, that signals will repeat after every particular interval of time. So therefore that signals will come under the periodic signals. Clear? Now this periodic signal, if we talk about for the continuous time period, that representation, the equation that must satisfy this periodic signal will be x of t is equals to x of t plus minus t. Any signal, if that signal will satisfy this condition, in that case that signal becomes the periodic signal. And if suppose that signal will not satisfy this particular equation, that means this particular condition, that signal will become the aperiodic signal. Here this t is nothing but the fundamental period of the function, that is x of t. This is the main, or you can say this is the time period, fundamental time period. For this particular time period, one cycle will be there and after that time period again for the same period of time, that cycle will get repeated. So here this t is the fundamental period of the time x of t. Here you can see this periodic signal should satisfy the two conditions again. What is that? it should exist from minus infinity to the plus infinity, and the value of this time period, that is t, must be finite. So here let us say one example. You can say, if suppose we will consider one signal here, fine. So let us say this is your one signal, that is, let us say your sine wave, fine. This is your sine wave, which will be varying here. So from minus infinity to the plus infinity. So one condition is satisfied, that is, the signal should exist from the minus infinity to the plus infinity. So here the signal will exist from minus infinity to the plus infinity, and again it is continuous in nature, fine. Here also it is continue, and here also it is continuous, fine. So your first condition is satisfied. Let us find out for the second condition. If we consider for this one cycle, this is your one cycle, and for this one cycle, let us say the time period is 2 pi. Fine, the time period is 2 pi. So here the time period is finite in nature. So therefore again the second condition is satisfied, that is t must be the finite, that is the time period must be the finite. If suppose these two conditions are satisfied, in that case again the signal becomes the periodic signal. So after this particular interval of time, that means t is equals to 2 pi, that is the fundamental period. So here if we consider again the second cycle, that is from this point to this point, if suppose that again comes out to be 2 pi, that means this is your fundamental time period. For a particular time period, that is 2 pi period, after that 2 pi period, again for the 2 pi period, the same cycle will appear. Again for the 2 pi period, the same cycle will appear. So this becomes your periodic signal. So the periodic signal must contain the two conditions. Again, that is nothing but it should exist. The signal must exist from minus infinity to the plus infinity, and the value of the fundamental time period should be finite. In that case, again, that becomes the signal becomes the periodic signal. And if suppose the first condition is not satisfied and the second condition is satisfied, in that case the signal becomes the semi-periodic signal. Here comes the semi-periodic signal. That means if suppose the signal should not exist from minus infinity to infinity, it will exist for a particular time period and the value of the t is finite. In that case, that signal becomes the semi-periodic signal. So again here consider one signal. Let us say this is your sine signal, and this signal will exist from 0 to, you can say, 4 pi. Fine, this is your 2 pi. So here you can see this signal will exist for only 0 to 4 pi. Before 0 it will not exist, and after 4 pi again it will not exist. That means here it is existence, the existence of this signal, it is for a particular time period, or for the particular, you can say for a particular time period only. It is not exist from minus infinity to the plus infinity. So therefore this signal, the first condition for this signal will not satisfy. But the second condition, what is that second condition? T must be finite. So here if we consider this one cycle, what will be the time period here? T will be 2 pi. And if we consider again the second cycle, again what is the time period? That will be the 2 pi. So the value of this time period, that is t, fundamental time period, is finite in nature. So here the first condition is not satisfied, but the second condition is satisfied, that t must be finite. So therefore such type of signals will come under the semi-periodic signal. So here what do you mean by the semi-periodic signals? That means the signals which will not exist from minus infinity to the plus infinity, but the fundamental time period is 2 pi. In that case, the signal becomes the semi-periodic signals.